One of the most unusual features of Banksia woodland is the way it recovers after complete removal of the original vegetation, such as in a sand quarry or clearing for roads or houses. A number of otherwise quite rare species begin to colonise the bare areas. But by far the most important is the woolly bush, Adenanthus signorum. Like Banksias, the woolly bush has a mat of proteoid roots which enhance nutrient and water uptake in these impoverished sands. It has extremely hairy, finger-like leaves which wrap around the stem and serve to reduce water loss. In fact, it can survive the summer without losing any significant amounts of water through transpiration if necessary. The juvenile plants have long branches indicating rapid growth, but no flowers. After 5 years, the stems become more divided and shorter, and flowering commences in spring and continues right through summer. But something else appears as well: calluses on the ends of some of the leaves called extrafloral nectaries. These are located near the flowers and developing fruits. While honey-eaters are attracted to nectar in the flowers, ants and parasitic wasps are attracted to nectar on the extrafloral nectaries. Even on a windy day, the ants are busy. These insect visitors are believed to benefit the plant by removing or destroying eggs or larvae of insect pests that they meet on the plant, especially the bag caterpillar, which eats the flowers and fruits, as well as the leaves. However, much more remains to be known about this intriguing symbiotic relationship. One of the most traumatic natural events with which the Banksia woodland has to cope at irregular intervals is fire. This area was burned by the Bushfires Board in mid-October as part of its program to reduce the amount of fuel around Jandakot Airport. It's 2 months now since the fire occurred, and there's been almost no rain over that time. But already we can see a tremendous amount of regeneration of the plants has occurred. Take, for example, the she-oak, Casuarina fraserana, which is developing a tremendous number of epicormic shoots arising from hidden buds underneath the thick bark which survived the fire. And beneath me we have Sterlingia latifolia, which is regenerating vigorously by many stems arising from its underground rootstock which survived the fire. And behind me we have the famous blackberry, Xanthorrhoea fricii, with its needle-like leaves arising from the apex. Now this apex is actually hidden deep inside the plant and has been protected by these persistent leaf bases which surrounded the apex and protected it from the full heat of the fire. And over here we have one of the native legumes which was killed right down to the ground level, and at the ground level we find in fact new shoots are arising from just underneath the soil. And over here we have Banksia attenuata, which is recovering from the fire by scores of epicormic shoots arising at many points along the old stem that survived the fire. And finally 1 or 2 of these will take over as the main branches of the plant in years to come. Looking at the ground flora, we see a tremendous number of species which look as though they're actually seedlings, but in fact that's not true because there's been no rain and hence no germination has occurred. In fact, these too are recovering from various underground parts which have enabled them to recover very much quicker than if they'd come from seedlings. Take, for example, this wire rush here, which when we dig it up we find that it has these thick roots on underground stems, and the very many apices that are giving rise to these new shoots were actually protected by the fire because they were actually underground at the time. And over here we have some other little plants, astrolomas and bossias and other plants which have all recovered via their underground roots. And over here we have one of the native irises, Papisonia occidentalis, which when we dig it up we find that it has a horizontal rhizome and many sheathing leaf bases which protected the delicate apices from the heat of the fire. And finally over here we have the well-known firewood Banksia, Banksia menziesii, and this is a small plant and we can see that the new shoots are arising from a swollen base here, which is called a lignotuber. And this is a source of hidden buds which emerge after the fire. The Banksia woodland was completely blackened by the fire 2 months ago. But already we can see that this Zania palm has recovered its full complement of fronds, and this was made possible by the presence of its apex being some 10 centimetres underneath the soil, which was protected from the heat of the fire. And this enabled the fronds to rise above the ground even in that short time. Now, Zamias exist as either male or female plants, and we can tell that this one is a female because beside it are a number of much smaller plants which must have arisen from seed dropped from this mother plant some years before. Most trees in Banksia woodland have wind-dispersed seed. Large quantities of mature seed are also released following the fire. This is the candlestick Banksia, which was scorched by fire while carrying mature cones. The branchlets supporting the cones were killed, which dried them out, causing the follicles to open. The two winged seeds are not dispersed immediately. They are held in place by a central plate, which gradually levers the seed out of the follicle, protecting them from the elements before they are dispersed. This area was control burnt by the bushfires brought just over 2 years ago, and we can see now quite considerable regeneration of the resprouters has occurred. Take, for example, this Adenanthus obovata, with its very strong new shoots coming from its lignotuber, and we see that the epicormic shoots in the Banksia menziesii are now well developed, and those in the she oak, Tegerina fraserana, too have made substantial growth in that 2-year period. But that's not the entire story, because in fact quite a few species are actually killed by the fire. Among the smaller plants we have quite a lot of species which must recover only from seed. So there are the two major types of recovery from fire, either resprouting or from seedlings. Now the problem with seedlings is that they must grow sufficiently to be able to flower and set seed again before the next fire. So this means that there's a certain limit to fire frequency in the Banksia woodland if it's going to be maintained. The other problem these days is with weeds. When the bush is burnt, the area is opened up, the nutrient availability is increased, and this increases the accessibility to the establishment of weeds. And so this is another problem that the bushland has to cope with. In the absence of additional fires, invasion by weeds, or clearing for development, the Banksia woodland will gradually return to equilibrium. The woolly bushes will disappear until the next disturbance, and the resprouters will again dominate, especially the Banksias. In this program I have tried to show the intricate and varied relationships that exist between the organisms in the often harsh environment of the Perth coastal plain. They have evolved over millions of years, and yet if their great interest and value to the people of Perth is not recognised, they could be lost in my lifetime. Programs such as this are no substitute for the real thing. Conservation begins with getting out into the bush and beginning to appreciate your natural environment.